Hi everyone. A few people have been telling me that they're having trouble understanding how to do the right angle triangle problems that we've been talking about in class. So I thought I'd create a quick video to help summarise what we've done so far. So let's actually go back to the beginning for a moment. Really briefly, we started this topic just by looking at where trigonometry comes from, and we introduced the unit circle. And the unit circle is really useful for trigonometry and helps us do lots of things. And often trigonometry is referred to as circular functions because of this unit circle. And this unit circle actually allows me to do lots of things with the trigonometric functions sine, cos and tan. And one of those things is to do a whole heap of graphs and modelling. Okay, and we're talking about things like graphs that model things like tides that go up and down, and we've got sine and cos graphs, but that's not where we're focusing right now. Also in our unit circle, we can create every single possible right angle triangle that ever existed within the unit circle. And because of that, trigonometry and the unit circle helps us do a whole heap of nifty things with right angle triangles. So the other thing that we study in trigonometry is triangles. That's not surprising, given what I've just shown you. And there's three types of problems we look at with triangles. Our first type of problem is right angle triangles. And that's what we've been studying the last couple of lessons. And we'll move on to non-right angle triangles later. And then we can also use trigonometry to find the area of triangles. And again, we come to that later. But at the moment, we're going to focus just on these right angle triangles. And for right angle triangles, again, we can break this up into three particular areas. We have problems for right angle triangles where we want to find the side length. And to find the side length, we can use multiplication. We also have right angle triangle problems where we find the side length using division. And we have problems where we find an unknown angle. And to do that, we use inverse trig, or inverse sine, cos and tan. Now for all of these problems, we end up having the same three trigonometric ratios that link to all of our right angle triangle problems. So those ratios are sine theta equals the opposite over the hypotenuse, cos theta equals the adjacent over the hypotenuse, and tan theta equals the opposite over the adjacent. So in all of these problems, O is the opposite, A is the adjacent, and H is the hypotenuse. And then finally, this symbol here, which I keep calling is theta, it is just a Greek letter, represents an unknown angle. And the easiest way to remember this, as we've discussed in class, is maybe not all of those formulas, but we talk about so, ka, toa. And so in this case, we've got sine is the opposite over the hypotenuse, cos is the adjacent over the hypotenuse, and tan is the opposite over the adjacent. So if we remember SOHCAHTOA, we can use that to help us solve our problems. And let's have a look at a couple of those problems now. And I'm going to add to that, the three steps that I use to solve these trigonometry problems are always the same for right angle triangles. I'm going to start by drawing it and labelling the sides. I'm then going to choose a ratio. So the ratios are the sine, cos and tan ratios, and substitute in what I know. And then finally, I'm going to solve the equation and check that I've answered the actual question. So solve the equation and answer the question. And it looks a little bit like this. Here are some problems that I have prepared earlier. So this is my first right angle triangle problem, and you would always be given some information in these problems that you're required to use to solve. And for any right angle triangle problem, we need to have two pieces of information and something that we're finding out. So step one, what I'm going to do first is I'm going to draw my diagram and I'm going to label my sides. Well, my diagram's already drawn here for me, so now I have to just label my sides. And in this case, this long side is the hypotenuse. So I'm just going to put a H next to it for hypotenuse. And this side down the bottom is next to the angle that I'm working with. So that's the adjacent. And I'm going to put an A for adjacent. So I've drawn my diagram, I've labelled my sides. I've done step one. I'm now on to step two. And step two is to choose a ratio and to substitute what I already know. So in this case, how do I choose a ratio? Well, I'm going to use what I know about these two sides to choose my ratio. And these two sides are the adjacent and the hypotenuse. So I go back up to my SOHCAHTOA and I say which one of these rules has the adjacent and the hypotenuse, and the answer is cos. So the ratio that I'm going to use for this problem is the ratio that cos theta equals the adjacent over the hypotenuse, and I'm also going to substitute what I know. So I know that the angle is 46 degrees and the adjacent is x and the hypotenuse is 7. Cool. We have done step two. Step three is I have to solve this equation. So when I'm solving it, I'm finding out what the unknown value is. So in this problem, I want to find out what x is. And on my right hand side of the equal sign at the moment, I've got x divided by 7. And if I want to get x by itself, I have to undo this divide by 7. And the opposite of divide by 7 is multiply by 7. So I'm going to multiply my right hand side by 7, and I'm going to multiply the left hand side by 7. I can do whatever I want as long as I do the same thing to both sides of my equation. So when I multiply both sides by 7, it looks like this, because the divide by 7 and the times by 7 cancel out, and I've now got an equation to work out what x is. And the only thing I have to do now is go to my calculator and type that in. So here is my calculator, and I want to do 7 times cos 46 degrees. And go to equals, and it's 4.86261. I'm going to round that off to one decimal place and make it 4.9. The questions might tell you how many decimals they want you to round off to. Always, and that's where the last part, which is answer the question that you've been asked, comes into it, because I need to reread the question, make sure I've actually answered the question. It might tell you one decimal place, it might tell you the nearest whole number. You need to actually read that information and make sure you have answered it properly. And that is my final answer for the unknown side. So the x value on this triangle would have to be 4.9. Let's have a look at another example. I should add, that is my case where I multiplied. Okay, so if we come back up to my problem up here, I talked about the different types of problems that you might have. That was an example where I multiplied to find the side length. All right, let's go to example 2. Here's my second example. It's got to be a right angle triangle, so look for that right angle. This side's x. We've got a 7 again, and this time the angle is 62. Alright, so step 1, I have drawn my triangle. I now need to label the sides. So I always label the hypotenuse first because it's the longest side and I can see which is the hypotenuse. But a trick, the hypotenuse is always across from the right angle. So hypotenuse, and then this side, it is opposite the angle I'm working with. So that side is O. Step 1, draw my diagram, labelled my sides, done. Step 2, I need to choose my ratio and substitute what I know. So in this case, I have O and H. So I go up to my rules and I look at SOHCAHTOA and I say which has got O and H in it. This problem here has O and H and the S stands for sine. So the ratio that I'm going to use to solve my problem is sine theta equals the opposite over the hypotenuse. And I also need to substitute what I know. In this problem I know the angle is 62 degrees, the opposite side is 7, and the hypotenuse is x. Now notice, as we move into step 3, which is the solve part, my problem here looks a little bit different to what it did before. Before, we had x divided by 7, and we could get rid of that divide by 7 by multiplying by 7. But in this case, we've got 7 divided by x, and I won't get rid of this 7 by dividing by 7. So I actually need to take 2 algebraic steps in this problem. And my first step that I'm going to take is I'm actually going to multiply both sides by x. What does that look like? Well, on the right hand side, when I multiply by x, then the divide by x and the times x cancel each other out, and I've only got 7. And on the left hand side, I would have x times by sine 62. This didn't really initially help me. I haven't got x by itself, but it is easy to get x by itself from here with one more algebra step. What I'm going to do now is I'm going to divide both sides by sine of 62, because that times by sine of 62 and divide by sine of 62 will cancel each other out. These will cancel each other out, and I am left with x equals 7 divided by sine of 62. And these sine, cosine and tan values, they're just numbers. They're programmed into the calculator. So from here, I have to just go to my calculator and work it out. So here we are back at the calculator, and now we want to do 7 divided by sine 62. I'm actually going to use my fraction button. You don't have to, you can just type in a divide sign and then sine 62, hit equals, and I get 7.927. This time, for no particular reason, I'm going to round off to 2 decimal places, and I'm going to say that the answer would be 7.93. So my answer for x would be 7.93. And so I've solved my problem. Now let's actually check that I've answered the question. One way we can check that we've answered the question correctly is a really simple analysis of, does this side make sense? Now this side was for the hypotenuse, and the hypotenuse is the longest side on the triangle. So one way I can check is just make sure that the answer I got is bigger than the other two sides. And in this case, 7.93 is definitely bigger than 7, so this answer seems logical. Alright, so that was my second example when I divided to find a side length. Let's have a look at my third example. The third example is when I'm finding an angle. Steps don't change. Number 1, draw a diagram. Here's the problem that I'm doing today in this example for finding an angle. I've drawn my diagram. Still in step 1, I also need to label my sides. So in this case, this is the side that is opposite the angle that I want to find. So it's the opposite. And this is the side that is next to the angle that I want to find. So it's the adjacent. Go to SOHCAHTOA. I won't scroll up again, I'll just rewrite it now. Go to SOHCAHTOA. Which one of these ratios has O and A in it? O and A. And we can see that the tan one has an O and an A in it. So for this problem, I'm going to use tan. So step 2, we write down our ratio. It is tan theta equals the opposite over the adjacent, and I substitute what I know. I don't know what the angle is, so I leave theta in there. I do know that the opposite is 5 and the adjacent is 5.6. So step 2, I've chosen my rule, I've substituted what I know, but this question's a little bit different because I'm not going to multiply or divide. This is not tan times by the angle. This is tan of the angle. That's a different function. And the way I undo tan, the way I do the opposite of tan, is I actually take what's called the inverse of tan. So I'm going to take the inverse of tan on both sides of my equal sign. And the inverse of tan, inverse tan, we say is tan to the minus 1. We call it inverse tan. It's the opposite of tan, so it undoes tan. Okay, what does that look like in reality? Well, the inverse of tan cancels out tan because they're opposites, which means on my left-hand side of the equal sign, the only thing that's left is theta, the angle that I'm trying to find. And on my right-hand side, I have to now also do the inverse of tan of 5 divided by 5.6. And you cannot do this in your head. You need to break out your calculator. So from there, all I've got left to do is to solve it using the calculator. I go to my calculator, and depending on your calculator, the inverse tan button is usually in a different color written directly above your tan button. So you've got to press shift or control or something like that to get tan. You've got to press shift or control to get inverse tan. On this calculator, I actually just hold down that button and I go inverse tan. And then we need to do inverse tan of 5 divided by 5.6. Go to equals, and I get an answer of 41.76. Or because we're in angles and degrees, we normally round off to the nearest whole number. I'm going to say this is closest to 42 degrees. So my angle would be 42 degrees. And then the 3 types of problems that you will get with right angle triangles. You are either going to find the side length by multiplying, and this happens, let's make a little note of when this happens. So the unknown is on the top, so multiply. Or you'll get a problem where you have to divide, which was our second problem. And a way to recognise this is the unknown is on the bottom. Now I should say the denominator, but we'll just work through it as being on the bottom of the equation. So it's a divide problem. And that's just a quick way that you can check. And then finally, if we are finding the angle, we use the inverse. And they're the 3 types of problems that you will get with right angle triangles. Let's look at one more example, and you try and work out which type of problem it will be. Alright, so here is my last problem for you to have a go at. We'll draw our diagram. This side's a 4, this side's a 73, and this side's an x. So my question for you in this video is what type of problem it's going to be, and you have to be able to work that out yourself. So take a little bit of time to analyse what's going on here. Now the very first thing that we spot is that we already know what the angle is. So if we know the angle, then it's one of the first two problems. We're finding a side length. So we know we're finding a side length, and it's going to be either a divide problem or a multiply problem. So how do we work out which one it's going to be? Well, I actually just let the equation do the talking for me. So go through our first step, draw our diagram, label the sides. This side is next to the angle, so it's adjacent, and this side is the longest side in my triangle, so it is the hypotenuse. So I look at SOH, CA, TOA, and one of those three rules that has an A and a H in it is my middle one. So I'm going to use cos to find out a side length. We still don't know whether we're going to multiply or divide. Step 2, we substitute. So we've chosen our rule. We know the angle is 73 degrees. We know the adjacent is 4, and the hypotenuse is x. Okay, now at this point you should be able to tell whether you are going to divide or whether you're going to multiply. And my hack here, or my tip, is that when the unknown value is on the denominator or on the bottom, it always ends up being a divide problem. So let's go through the algebra to solve this using a divide problem. The first thing I do is I multiply both sides by x, which makes my equation x times cos 73. Remember, mathematicians are lazy. They don't bother writing times signs in when they're doing algebra. And then the last thing that we're going to do is we're going to divide both sides by cos of 73. So divide both sides by cos of 73. They cancel out. I'm left with x is equal to 4 over cos 73. Lastly, can't do that in my head. I need to break out the calculator. I use the fraction button, and 4 divided by cos 73. Get my answer, 13.6812. So 13.6812. I have solved the problem. The last thing I've got to do is just quickly check the question, have a look. Did it tell me how many decimal places? Did it tell me to go to a whole number? Make sure you answer the question properly. In this case, I'm just going to round off to 1 decimal place because today I feel like going to 1 decimal place. And that's the end of the video. Thank you for